So the shape of a normal sine graph is going to start at 0. It's going to go up, and it's going to look like this. Okay, so that's the general shape of a sine graph. Now, if there is a reflection over the x-axis, then that graph will still start at the same place, but it's going to go down first. Does that make sense? Okay. Similarly, for cosine graphs, a normal cosine starts at the positive amplitude and looks like this. And so a reflected, which I'm just going to draw an arrow to these, a reflected cosine graph is going to start at the negative amplitude and would look like that. Okay, so knowing this, if you're really struggling with figuring out what the points are, you can still at least know kind of the general shape it should follow. Does that make sense? Okay. So, couple of reminders. The number out front of these graphs, that A, that is the amplitude. Specifically, it's the absolute value of the amplitude. We always want to write amplitudes as positive numbers. Okay. So to find the period, what do? Yeah, we do 2 pi divided by b, and that's going to be equal to the period. Now, if I want to find the increments, what do? Yeah, so I do 1/4 times whatever that period is. Okay, so what we didn't do last class that we're going to do today is what we call a phase shift. So phase shifts are when we're moving to the left or to the right. Okay, and then we did do this last class, a vertical shift up or down. Okay, any questions so far? All right, let's just jump in. So, for this one, what's my amplitude? 2. Okay. To find the period, I'm going to do 2 pi divided by 3, right? This 3 right here. So that is the period because we can't really simplify that. So Vs is going to represent that vertical shift. So what's my vertical shift? Up 2. And then PS, that represents the phase shift. Okay, so that's moving to the left or the right. So how am I moving?
To the right.
I'm moving to the right, pi over 3. Right here. Okay. That left and right shift, it's not going to change our domain because our domain is still negative infinity to infinity. So it's really, adding that phase shift in is not going to change any of these values from what we previously did. So typically my range is the negative amplitude to the positive amplitude, right? So negative 2 to 2, but then I'm shifting up 2, so what should it be? 0 to 4. Okay. So next we want to find my increments. So to find my increments, what am I going to do? 1/4? Mm-hmm. Right, because we're always going to have 4 increments every single time. So what are my increments? Yeah, so this would end up multiplying out to be 2 pi over 12, which does reduce to pi over 6. Okay. And do I have any other transformations I need to worry about? I do. I have a negative out front, so that means I am going to have a reflection over that x-axis. So what that means is that my graph, it's a cosine and it's reflected. It's going to look like this. It may be moved around slightly, but this is what it should look like. Does that make sense to everybody? Okay. So when we're doing a graph with a phase shift, so normally I would start at 0, correct? Yes? But because I'm shifting to the right pi over 3, my first value is actually going to happen at pi over 3. Okay? And from there, I'm going to do 4 increments of pi over 6. Does that make sense? Pi over 3? Because I shifted to the right pi over 3? Yeah. Are we okay? Okay. So the problem is if I add pi over 6 to pi over 3, they don't have a common denominator, right? Yes? So how could I write pi over 3 with a denominator of 6? 2 pi over 6.
Wait, why did you do that?
Because I'm going to add pi over 6 each time to get my increments, and so they got to have a common denominator in order for that to happen. Okay. So if I add pi over 6 to this, that means my next tick mark is going to be 3 pi over 6. But what does that reduce to? Pi over 2. My next tick mark before reducing is going to be what? 4 pi over 6. And so then after reducing, it would be 2 pi over 3. Okay. The next one's going to be 5 pi over 6. Does that reduce? No. So we'll just leave it. Okay. And the increments are like between the two numbers. Do we understand that? So from here, I only have 1, 2, 3 increments. Does that make sense? So I need to add another pi over 6, which would be 6 pi over 6. And what is that going to be? Pi. Alrighty. And then I'm also shifting up 2. Do we understand that? So when we draw our graph, it should go through that line of 2. All right. Trying to figure out. Okay. Maybe I'll change it. I don't know. Okay, so again, I'm shifting to the right at pi over 3, so my first value is going to happen at pi over 3. Does that make sense to everybody? Does cosine typically start at the amplitude or at 0? The amplitude, right? So typically you would start at the amplitude of 2, correct? And then it's going to have to reflect, so it'd be at negative 2, right? And then it shifts up 2, so where is it going to be at? 0. Okay, so next cosine would be at 0, right? Is the reflection going to affect that? No, so it's going to shift up 2. So it's just going to be here. Okay, I also want to point out that, again, this first point is the amplitude away from that reference line. Does that make sense? Do we see that? So then I can go the amplitude above that reference line. So where should my next point be at? 4. And then where should I be? 0, but up 2, so it'd be at 2. And then finally I'll be at 0, back where I started. Right? And so the graph will look something like this. So there is a couple of ways to do this. some people like to draw the graph like normal and then shift it up 2. Some people draw the reference line and just graph it based upon that. And some people think about the transformations as we're doing them, like starting at that amplitude, reflecting, shifting over and up. Does that make sense? So there is more than one way to do this. You just need to find what works best for you. Okay? Can I go? Yeah? And so do we also see how this graph looks like this one? Again, just shifted. Okay, so it should still maintain the same shape. Okay, so for the next one, what is my amplitude? 2. So to find the period, I would do what? 2. So it's pi. The vertical shift is up 1. And the phase shift is right pi over 6. Domain is still going to be negative infinity to infinity. And what's range going to be? Negative 1 to 3. Yeah, I can. So range is negative amplitude. So like -2 to positive amplitude. Okay, right? But then I'm shifting up 1. So that means to both of these values, I need to add 1. And that's what gives me the range. Yeah, so it's always negative amplitude to positive amplitude, and then the shifts up and down change that. But you're always adding the same to both of them. Okay? Okay, and then to find my increments, I'm going to do 1/4 times the period, which is pi. So my increments are going to be in pi over 4s. Okay. So again, usually we'd start at 0, but because I'm moving to the right pi over 6, I'm actually starting this time at pi over 6. Does that make sense to everybody? And how much am I going to increase by each time? Pi over 4. Do we see that? Okay. Slight problem with that, though. They don't have common denominators. Do we see that? So we got to force it to make it work. So what would be a common denominator that we could get for both of them? 24, but we could go a little lower than that. 12. Do we see that? So how can I rewrite, let's start with pi over 6, as something over 12? 2 pi over 12. Does that make sense? And then how can I rewrite pi over 4 as something over 12? It would be 3 pi over 12, right? We're multiplying the top and the bottom by 3. The last one we multiplied the top and the bottom by 2. Are we okay? Okay. So that means for our first increment, we'll add 3 pi over 12 to this 2 pi over 12. So what is that going to give me? 5 pi over 12. Does that reduce? No. So we're just going to write it like that. That's okay. And do you see how that's like our first increment, that space in between? So that's the first one, so we need 3 more. So what would the next one be? Does that one reduce? Yeah, what would it be? 2 pi over 3. The next one would be 11 pi over 12. That one doesn't reduce. And again, we have 1, 2, 3 increments. We need 1 more. So the last one would be 14 pi over 12, which reduces to what? 7 pi over 6. Very good. Okay. And again, I'm shifting up 1, right? So that reference line, that line that's cutting my graph in half, should be happening at 1. Do we understand that? Okay. So, sine typically starts at 0 or at the amplitude? 0. But then I'm shifting up 1, so where should this start?
1.
At 1. So at pi over 6, 1. Okay. Does the sine graph, again, I'm not reflecting on this one, so should I go up or should I go down? I should go up, right? So I need to go up beyond this line, the amplitude. So where would that take me?
2.
3. Do I need to explain that? Okay. So next it would go to the amplitude, right? But then it still has to shift up 1. So the amplitude is 2, so it has to shift up 1, so it'd be at 3. Okay? Nope. It doesn't change the amplitude. Because the amplitude's going to be like the distance from this reference line to this point. Does that make sense? So that distance always has to stay as 2. Okay? Next, where will it go? Back to 1. Okay. And then where do we think it would be? Negative 1, right? Because it would be at the negative amplitude, which is negative 2, but then shifted up 1, right? So that's negative 1. So that's like, oh, it's going to be in the middle of that thing. That's fine. And then we always end back where we start, right? So it's going to end back at 1. Okay? And so this is that sine graph. And again, it should look like the sine graph we drew earlier. It should still have that same shape, just maybe moved around a little bit. How are we feeling? I love you guys. I'm so sorry. Okay, we'll just keep practicing. Can I go? Okay. So, we're going here. So, what's the amplitude here? 3. You okay? Okay. So, for the period, what am I going to do?
2 pi over 6.
2 pi, which is pi over 3. Do I have a vertical shift?
No.
Nope. Do I have a phase shift?
Yes, it's left on pi over 6.
Mm-hmm. Yep, I'm going left pi over 6. My domain stays the same, negative infinity to infinity. What about my range? Yeah, it's going to be the negative amplitude to the positive amplitude. Alrighty, so we understand we're going to the left, right? So I maybe need to see more of the left side of my graph than I have previously, right? We've stuck pretty much with the right side. Do we understand that? So now I'm moving to the left. Okay, so if I'm moving to the left pi over 6, where is this graph starting? Negative pi over 6, very good. Okay. And before I do that, I do need to actually find my increments. So to find my increments, what am I going to do? Yeah, so 1/4 times the period. So it's going to be pi over 12. Yes, there is also a reflection. Okay. So, I need to increase by pi over 12 each time. Does that make sense? So how can I rewrite negative pi over 6 with a denominator of 12? Negative 2 pi over 12, right? So if I add pi over 12 to that, what is that going to take me to? Negative 1 pi over 12, which we can just write as like negative pi over 12. Does that make sense? Okay. Now, if I add pi over 12 to that, where is it going to take me? 0. Do we understand that 0 is like here? Yeah? Okay, because people in my last class added a tick mark for 0. So don't do that. Okay. So that gives us 1, 2 increments. So then we have to add another pi over 12, right? So it's a positive pi over 12. And then I got to add, I have 1, 2, 3 increments. I need to add one more. So what is that going to be? Yeah, 2 pi over 12, which is pi over 6. Okay, the nice thing though is I'm not shifting up or down, right? Okay. So, does cosine start at 0 or at the amplitude? At the amplitude, right? So normally it would start at 3, but if I'm reflecting, where is it going to start? Negative 3. Right, so we'll call this negative 3. So it's going to start here. Where does cosine go next? Yeah, it's got to hit 0 before it can go to the positive amplitude. Does that make sense? So where is it going next? 3. And then it goes back to 0 and back to negative 3. Also, please try not to draw your graph like a straight up U. Like, try to give it a little, like, curve on the end, because a U is a parabola. So we want to make sure it looks like a cosine or a sine graph. Questions? Great.
I need to do it again.
Yeah.
I don't have questions, but I don't know what I'm doing.
Okay.
That's how I felt all year in sixth class. Like, you just explain stuff.
Okay. Amplitude. 2. Okay. Do we understand that? Yes?
Yes.
Okay, that part we got. Period. We would do 2 pi divided by pi over 4, right? And if I'm dividing by something like that, what do I need to do? Multiply by the reciprocal. So I need to do 2 pi times 4 over pi. So the pi's are going to cancel, right? So what am I going to get there? 8. Do we see that?
Sure. Uh-huh. So you just look.
Yeah, you just because when you're like dividing by a fraction, you can like flip the fraction and change it to multiplication. Okay. Vertical shift. Down 1. Oh, yeah, I got that one. Hey, that's our the point. So I'm just saying, like,
Okay.
we're gonna take our points where we can get them.
Oh, so as in,
The graph will be probably at least 2.
okay. And everything else, like all the little questions, the amplitude here, is that all one way?
I think I have to ask Miss Nash about that. Okay. Phase shift. Where am I going?
Right one.
Right 1.
Look at me.
Look at you go. Domain is all reals. Okay. Range would normally be negative 2 to 2, right? But then I'm moving down 1. So what is it going to be? Negative 3 to 1. Because negative 2 to 2,
Oh, 2. Okay, yeah.
So it's always negative 2 to 2?
it's always negative amplitude to positive amplitude. So like in the last one, it would have been negative 3 to 3.
Okay.
And then if it had moved, it didn't move up or down, but if it had, that would have
So
changed
it's
it.
just the amplitude?
Yeah, in the negative and the positive. And then it shifts up and down from there. Okay. So, to find my increments, what am I going to do? 1/4 times 8, which is 2. And then, do I have a reflection?
Yes.
Yes, I do. This one's a little nicer because you're not going to have to deal with pi. Aren't you so excited? Sure, okay.
You put one where we don't have to do one.
No promises. Okay, so if I'm shifting to the right one, where am I starting? At 1. Okay, and then my increments are by 2, so what should be my next tick mark? 3, and then 5, and then 9. And that gives us 1, 2, 3, 4 increments. Okay? And I'm shifting down 1, right? So that means at negative 1, that's where my like reference line is. Do we understand that?
Wait.
My like little reference line should be there. Okay. Where do sine graphs usually start? At 0, but I'm shifting down 1, so where should it start? Negative 1. Okay, so if it's a negative sine graph, should it go up next or should it go down next? Down. Do we understand that? Okay, so it would go down to the negative amplitude, but then it's still got to go down 1 more. So where is it going to? Negative 3. Do I need to explain that again? Yeah, I can. Okay. Okay, so you can, again, there's a couple of ways to think about it. So normally sine would go to the amplitude, right? Which is 2. But we got to reflect it, so that takes it to negative 2. Yes? And then we have to shift it down 1. So that takes it to negative 3. The other way we can think about it is, again, if it's a negative sine graph, that means I have to go down first. Does that make sense? And I need to go down from this reference line 2 units. Okay? So if that reference line is at negative 1, going down 2 units takes me to negative 3.
Okay.
Where am I going to go next? Negative 1. And then I'm going to go to 1. Because I would go to the amplitude, which is 2, but it's got to move down 1, so I'm going to 1. And then where am I ending? Negative 1, because I end where I start. And so my graph should look like this. Okay, so this again goes back to that shape of that reflected sine graph. It should still have that same shape. Okay. We're on our last one. Yay. Okay. Amplitude is 2. So for the period, I'm going to do 2 pi over pi, which is 2. Up 3. Right 1. All reals. Okay, so even with the reflection, it's still negative 2 to 2. That doesn't change. And then we shift it up 3, right? 5 and 5 and positive 1, right? Because it'd be negative 2 to 2. Negative 2 plus 3 is going to give us 1, and 2 plus 3 is going to give us 5. And if you need to write out that step, you're more than welcome to.
I like, now that I get that, I write it out.
Do you want me to write that out real quick?
Sure.
Okay, so it's negative 2 to 2, right? And then we're shifting up 3 for both of those. And you're more than, like, I'm not going to, like, dock you points, as long as you write the correct answer in that final space. Okay? So, increments, I need to do what? 1/4 times 2, which is going to be what? 1/2, right? It'd be 2/4 or 1/2. Okay. And do I have a reflection? Mm-hmm. Okay, so again, I'm shifting to the right one, so that's where that first is going to start, and each time I have to add 1/2. Do we understand that? Yeah? So how can I write 1 as a fraction with a denominator of 2? 2 over 2. Do we understand that? So what should my next tick mark be? 3 over 2. Then it would be, yeah, it'd be 4 over 2, which is 2. Do we understand that? Yes? Okay? Because no. And so then the next one would be 5 over 2. But I only have 1, 2, 3 increments, so I need one more. Where is that going to take me? To 3. 6 over 2, which is 3. All right, and I'm also shifting up 3. So I do have that reference line happening at a positive 3, right?
So whenever you go up, like, can you shift up or down that direction?
Yeah. Mm-hmm.
Because that is your name.
Yeah. So, does cosine typically start at the amplitude or at 0? It typically starts at the amplitude, right, which would be 2. But I'm going to reflect it, so it would be negative 2, right? And then I still have to shift it up 3. So where is it going to be? At 1. Okay. Where would cosine go next? 0, but that's then up 3, so it would be at 3. Where would it go after that? It would go to 5. Do we see that? Right? So it would go to 5 next. And then it would go back down to 3 and back down to 1.
Wait, why don't we start at 1?
Okay, so normally we would start at the amplitude, right, which is 2. Then we would reflect it, so that's negative 2, correct? And then we shift it up 3. Okay, so again, the other thing I want to point out is from this reference line, do you see how it goes the amplitude in the positive direction and the amplitude in the negative direction? So that's like a nice way to check yourself. Okay. We do have classwork.